Welcome back, everyone. In today's class, we'll be dealing with the alternating current 1, and we'll have to deal with a couple of basic things on the AC circuit. And I hope that you pay rapt attention and that you get every essential thing that is required. Alternating current 1. So here, I'll be talking about, we'll start by talking about AC circuit. I will establish that AC circuit that is dealing with alternating current, alternating current circuit, a circuit through which an alternating current flows. Such circuits are used extensively in power transmission, radio and television, computer, technology, telecommunication, and in medicine. So please take note of this, the uses of this circuit. So let's go to another paragraph and say it varies. Why it is called alternating is because it varies sinusoidally, or what we sometimes call periodically, in such a way as to reverse its direction periodically. So the commonest form, we'll talk about equations. Commonest form such AC or alternating current is represented by this equation that you see here. You know, we're talking about current, so we have I equal to I naught, that's I subscript 0 or I subscript O, I naught sine 2 pi ft. So some can write this as I naught sine Wt. You know why? Because W equal to 2 pi f. So please take note of this. I've started again with the formula notice. Very important. And right here, it is good to note that I is the instantaneous current, as the instantaneous current at a time t, while I naught is the maximum, or we say peak, or peak value of current. So, or we can call it, or the amplitude. Take note of that. I naught. I'm regarded as the amplitude. We often know F. F refers most times. F is the frequency. That's common knowledge. And then W, in this case, we call it omega, is angular velocity. Angular velocity. So that W, like we said earlier, is equal to 2 pi ft. While the Wt itself together is the phase angle. Take note of that. Wt is phase angle. So if you recall, I is equal to I naught sine Wt, or I naught sine 2 pi ft. So this entire Wt is phase angle. It's like theta. So this theta is phase angle. So the entire thing. So get that point down. No, when you say sine something, sine phase angle, that means Wt, the entire thing is phase angle. So we are building the structure. Also, if we write the AC equations in terms of voltage, we have V equal to V naught sine 2 pi ft, which can also write as V naught sine omega t. See that? Just in similar fashion as current. So please just take note of these powerful equations. So in the same vein, you can create your list for each of them. This is instantaneous voltage. At time t, this is like the amplitude, but more we call it maximum or peak value, peak voltage, peak or maximum voltage. Amplitude voltage. So in a similar fashion, every other thing we have defined this as defined as before. FW, omega t, everything is frequency, angular velocity, and then its value. So let's go straight to an example so we know what we're doing by utilization. Let's take this. If an AC voltage is represented by P equal to 4 sine 900 pi T, is to calculate the peak and instantaneous voltage. Now, just from what we have exercised ourselves running through just now, we compare what we have in this question versus our standard formula. We know that V equal to V naught sine 2 pi ft. So if we compare it with V equal to 4 sine 900 pi t, we can say, oh, these two are first equal. So V naught equal to 4. So we can say categorically that yes, we have V naught equal to 4 volts. Set to that one. Then we can now compare and say, okay, 2 pi ft equal to 900 pi t. That is, these two are also equal. So if we do that, we can cancel this, which I've told you not to do. You can just do that in your mind. And t, these two cancel this. So we're left with 2f equal to 900. So f equal to 900 over 2. So we have 450 hertz. And we know that omega is 2 pi f. So that's more like 2 pi times 450. And that is 900 pi. So settled f, settled w. So they asked us to find the peak and instantaneous voltage. Okay, we already know we found the peak voltage. The instantaneous voltage is a regular guy that we have even from the question, and that is 4 sine 900 pi t. So this one is already the same thing from the question. So assuming they ask us to find it at the instantaneous voltage at a particular time, we'll just plug in that time and we'll get a value. But I think the main thing that the question asks us to find is peak voltage, and it could have asked us to find frequency, could have asked us to find this. But then, yeah, if it's actually asking us to find an instantaneous voltage, it would have given us a time. Just keep that in mind. Let's move to the next subheading. So we're going to say variation of alternating current say or voltage with time. How does it vary with time? So the idea is you have time, you have current. The same thing applies to voltage. You have voltage, you have time. So that is how it is. So I can write, see that is how the graph looks like. So I can state that an alternating current or voltage varies sinusoidally as shown in the diagram above. It is a sine waveform. You can say the amplitude. The amplitude. And if I go back, amplitude is like the maximum stuff reached. That's the maximum. So this is like VO, the maximum. So why this one, the maximum stuff here is IO. So the amplitude or peak value, you see it as a similar name, the amplitude or peak value of the current IO is the maximum. So as me has to define amplitude or peak value, it is the maximum numerical value of the current. The same thing applies to voltage too. So we can say the amplitude or peak value of the voltage is the maximum numerical value of the voltage. That is how it works. Now let's talk about something different. There is something called the root mean square. The root mean square RMS value of the current is the effective value of the current. See that word effective. So and the same thing applies to voltage too. So any definition that applies to current should also apply to voltage. Just keep changing the word current to voltage, and then you're good to go. And describe it as so. If you want to give it another proper definition, we say it is that steady current which will develop, this definition very important, which will develop the same quantity of heat in the same time in the same resistance. See that definition? It's the steady current which will develop the same quantity of heat in the same time in the same resistance. So, and it is normally given by IRMS. Write it up. So subscript is peak value over root 2. See, put this in your mind. And whatever you see here that applies to current applies to voltage as well. I can quickly write that the root mean square, the root, I want to just repeat what is here, but for voltage now. The root mean square RMS value of the voltage is the effective value of the voltage. It is that steady voltage which will develop the same quantity of heat and the same time in the same resistance. So keep that in mind. Then we have, you can write it as V RMS equal to V naught over root 2. So please keep this in mind. So let's make some other points. There is a very short class. Let's make a couple more few points before we call it a wrap. The moving coil. Now let me keep that in red. The moving iron core, iron and hot wire meters measure the average value of the square of the current called the mean square current. So the idea here is that IRMS square, when you square that, that is the mean square. You understand? So talking of the instruments used to measure them, moving and not wire meters, they are normally calibrated. They are, however, calibrated in such a way as to indicate the RMS current directly. So most AC meters read the effective or RMS values. The average value of an AC voltage is 0. So take note of that last statement. So we'll call it a wrap. That was a very short class, but keep that in mind. Let me give you a take home. Let's call that homework. Number 1. So let me put it like this. Calculate I think, okay. Let me just make it 1. A 50 hertz AC circuit has an RMS voltage of 220 volts and a current and a RMS current of 5 ampere. Determine the peak values of the voltage and current. So take note of that. So we'll meet in our subsequent class.